Hello everyone, we're going to move on from the solving linear equations stuff that we've been doing over the last couple of days and move on to discussing linear relationships, which is the starting point for going into the graphing stuff that is really one of the main focuses of this unit. So let's start with a scenario. It's going to be a scenario that's quite similar to some of the ones that we've seen in the exercises we've been doing over the last couple of days. But I think it's good to start with a scenario that can launch us into understanding some of the concepts. So let's have a look at this. To hire a particular DJ costs a flat rate of $400 per gig for setup costs plus $150 per hour of the gig. The first thing that I want to do is write an equation to summarize that information. So as always, if we're writing an equation, I need to start by assigning variables. So I'm going to say this. I'm going to say that C is the cost of hiring the DJ, the total cost, and that'll be in dollars. And T is the total time that the gig goes for, and that would be in hours. Those are the two variables presented to me in the question, so I've assigned those to C and T. And now we can write an equation using those two variables. So what does the total cost equal? Well, it's $150 per hour. So that means that for every 1 hour, it's another $150. So I need to do 150 times by T. And then there's an extra $400, which is a flat rate and doesn't depend on the time of the gig at all. So I get this equation here, C equals 150T plus 400, or in the language of the question, the total cost of hiring this DJ will be $150 times the number of hours that the gig will go for, plus $400 for setup costs. Okay, let's see what we can do with this equation now. The first thing that I want to do with it is fill in a table of values. So I've got the equation up the top there. Let's say that my gig went for just 1 hour. If my gig goes for 1 hour, then my cost would just be $150 for the 1 hour plus $400 for setup. So that'll be $550. If it goes for 2 hours, then it'll be 150 times 2, so $300 for the time, plus still the $400 for the setup, so that's going to give me a total of $700. And in a similar way, I could continue to go through the whole table. Oops, I raised a bit too much there. So we've got 1 hour is $550, 2 hours was $700, and I could continue to fill that in. 3 hours would be $850, 4 hours would be 1,000, and 5 hours, oh, I forgot it, left a 0 off there, and 5 hours would be 1,150. Okay, let's now take that table of values and move on to see what else I can do with this information. And the next thing that I want to do is draw a graph. So up in the top right corner there, I've got the table that we drew on the last slide. And I've got a graph over here that I want to fill in, where on my y-axis, I'm plotting the total cost of hiring the DJ. And on my x-axis, I'm plotting the total time in hours that the gig will go for. Let's use the table of values to fill in the graph. Let's plot some points. The first one, if t equals 1, then the cost will be 550. So 1 and up to 550, that'll take me to about there. Then I'm going to say if time is 2, then the cost will be $700. So that's going to take me halfway between the 600 and the 800, round about there. If the gig goes for 3 hours, that'll take me all the way up to 850. About there. 4 will take me all the way up to 1,000. Now, hopefully what you can see here as I continue to fill this in is that these dots are creating a straight line. if I were to join these dots up, which I'm going to do in a second, I'm going to get a perfectly straight line between them all. Let's see that. Let's join these dots up. Now, my straight line is not going to be super accurate, but we'll do our best. There we go, not bad. I've got a straight line between all my data points. Now, that gives us a really important bit of information. We've done three things with this scenario. We've written an equation, filled in a table of values, and drawn a graph. And with this graph, we can see that our two variables have a linear relationship. And this graph gives us the first way that we can think about what a linear relationship is. And that is if I plot my two variables on a graph and I get a straight line between them, then I've got a linear relationship between the two of them. That also gives rise to another really important concept that's going to be the focus of what we're doing here, and that is the idea of the gradient. Now, conceptually speaking, I can think of the gradient as being how much does one variable change when I change the other by a certain amount. Let's put that into real terms and see what does the gradient have to do with the graph. On a graph, I can think of the gradient as the steepness of my line. So if I have a linear relationship, I'm going to get a straight line on my graph, and the gradient is the steepness of that line. How do I measure steepness? Well, I measure it by, for every 1 unit that I have to go across my graph, how many units do I have to go up to hit the graph again? Again, for every unit that I go across, how many units do I have to go up? That gives me the gradient or the steepness. How steep is my line? The easy way to think about that when we're looking at a graph is that it's the rise over the run, and that's probably a term that you've heard before, the rise over the run. How much does my graph rise for every unit that it runs? So in our situation here, let's just do an example. Let's take this data point here, where it's the data point for 1000. To go across to 5, I've run across 1 unit, and to go across 1 unit, I have to go up from 1000 to 1150. So my rise is 150 from 1000 to 1150, and my run was 1. And 150 over 1 is just 150. So it gives me a gradient of 150. That's my number for how steep is my line. Well, it's 150 steep, right? It's a gradient. It's got a gradient of 150. Let's look at another way that we can think of the gradient. If I jump back to my table of values, for every 1 that I go across the top here, for every 1 that I go across the top, how many do I have to go across the bottom? It's the exact same thing as we were doing before on the graph, just looking at it through a table of values rather than the line on the graph. So to get from 550 to 700, I've got to do 700 minus 550, which gives me that same answer of 150. So I've got a gradient of 150. Using this table of values, we can also come up with another way of thinking about what it means for two things to be a linear relationship. To be in a linear relationship means that if, as I go across here, my top row or my one variable is changing by a constant amount, in this case 1, then my bottom row, my other variable, will also change by a constant amount, in this case 150. Okay, let's go back and look at one more way of thinking about linear relationships and gradients, and that's jumping all the way back to the equation that we wrote at the very beginning. Every single linear relationship, the equation for it follows the same format, and that's the format of y equals mx plus c. And I'm sure that that's something that you guys have seen before, but let's just go over it and make sure we understand what it all means. Y is the value that I plotted on my y-axis. In this case, it is the C, the cost of hiring the DJ. The X is the value that I plotted on my x-axis, which in this case was the time, the number of hours that the gig was going for. The C in my formula y equals mx plus c is, we'll come back later to what it means on the graph, but for now let's think about it as the fixed cost for the gig, which in our situation was $400, and that leaves M. M is the gradient. So that gives us another way to think of linear relationships and gradients. If my relationship between two variables can be summarized using a formula that follows the format y equals mx plus c, then they must be in a linear relationship. And if that is the case, then whichever number falls into my M position is the gradient of my relationship, which in this case, as you can see, is 150. Let's summarize what we've spoken about. First of all, linear relationships, we can think of them in three different ways. If I plot two variables and it gives me a straight line graph, then they are in a linear relationship. Secondly, a linear relationship is one that follows the y equals mx plus c format. And the more conceptual way of thinking about it is if I change one variable, then the other one will change at a constant rate. The second thing is the idea of the gradient. A gradient conceptually means when I change one variable, how much does the other change by? That gives me the gradient of my relationship. Secondly, I can think of it as the steepness of my graph. If I plot the two variables, get a straight line, how steep is that graph, which I can calculate as the rise over the run. I could also think about it as the change in the bottom row of the table, like we did before when we got 150. And lastly, I can think about it as whatever number is in the M position of the equation that fits the y equals mx plus c format. Okay, that's the end of this video. I'd like everyone, please, for the lesson tomorrow to try these 4 questions. It should only take you a couple of minutes from exercise 8A, and then we'll spend the lesson going over those questions, the rest of the questions from that exercise, to make sure that we understand all these ideas.